say things that are crazy, and we should be good to go. Okay, so guys, we're going to talk about rules of exponents. These are all things you've seen before. If you were a Woodward student for more than 2 years, you learned this across the street at that other school over there. But we're going to review it. What makes this hard or difficult is when all these things get blown into one thing and you have to know all these rules. Now, you're not going to be tested on what's the power of a product rule, what's the product of power. I'm not going to test you on the names of these. It's really more about, do you know the rules and how to apply them, okay? Product of powers. Product means multiply. So when I've got the product of a number raised to different powers, a to the m times a to the n, what do I do with those exponents? I add them. So this is 5 to the 3 plus negative 1. What's 3 plus negative 1? 2. So this is 5 squared, which is what? 25. Okay. Okay, pretty cool with that. Power of a power. A to the m raised to the nth power. See how that's different than this? So in this case, those exponents, what do I do with them? I multiply them. So 3 cubed squared is 3 to the 3 times 2, which is 3 to the 6th power. Okay. Which is, let's just do that real quick. I don't know that one off the top of my head. 3 to the 6th power is 729. Okay. Power of a product. So I've got a product, AB, and I'm raising that to the nth power. So what's being raised to the nth power? Two things. Everything in that parentheses is being raised to the power of m. So it's a to the m, b to the m. Okay? So in this case, 2 times 3, all of that raised to the 4th. I got two ways of looking at this. And in many of these problems, you're going to have two ways of looking at this. What's 2 times 3? So I could write this, that's 6 to the 4th power. Okay? 6 to the 4th power is, what is that? That's 36 times 36. What is that? I don't know that off the top of my head. 36 times 36. 1296. So equal 1296. Another way of thinking about this is 2 to the 4th times what? Times 3 to the 4th, which is 16 times 81, which is 1296. Okay. So this illustrates something we're going to see all day today. There are multiple ways of interpreting the exponents using the rules, but getting to the same answer. Okay. So in this case, everything in the parentheses is raised to the 4th power. So 2 to the 4th, 3 to the 4th, or multiply first and then raise all of that to the 4th power. Quotient of powers. So anytime I have a quotient of the same thing raised to different powers, what do I do with these exponents? I subtract them. A to the m over a to the m is a to the m minus n. So in this case, this is 6 to the minus 3 minus negative 6. What's 3 minus negative 6? Positive 3. So this is 6 cubed, which is 36 times 6, and that is, I think, 216. Now here's your first mistake of the semester in your book. A over b to the m power. What's being raised to the power m? A over b. So a over b to the m is a to the m over b to the m. Okay, so it should look like this. A to the m over b to the m. Okay, so if I see something like this, 4/7 squared, that's equal to what? 4 squared over 7 squared, which is 16 over 49. Okay, pretty cool with that. Negative exponents. This trips people up, but you guys are going to be okay with it. Anytime I see a negative exponent, I can make that exponent positive just by moving it. If I find it in the numerator with a negative exponent, it will become a positive exponent when I move it to the denominator. If I find it with a negative exponent in the denominator, it will become positive when I move it to the numerator. Okay? So 7 to the negative 2 is 1 over 7 squared. Because if I look at this, that was a negative exponent in the numerator. It became a positive exponent when it moved to the denominator. What's this? 1 over 49. Okay? Let's see. Oh, are you going back to Kristen, Miss Reagan? Can you give those to her? Okay, this 0 exponent. Anything other than 0 raised to the 0 power is 1. Okay? So 0 to the 0 is indeterminate. It's undefined. Anything else to the 0 is 1. So negative 313 to the 0 is 1. Okay? Any number other than 0 raised to the 0 power is 1. Okay? Don't let that one's easy, but don't let it trick you up. So let's start applying some of these rules. I want to simplify these, and in my simplification, I never want negative exponents in my answer. X squared times x cubed. What do I do with these exponents? Yeah, this is x to the 2 plus 3, which is what? X to the 5th. X squared to the 3rd power. What do I do with these exponents? Multiply them. This is x to the 2 times 3, which is what? That's x to the 6th power. The next one here. What is being cubed? X and y. Both of these are cubed. So this is x cubed, y cubed. Can I simplify this and add the exponents? Why not? Two different things, okay? If this were x cubed, x cubed, that's x to the 6, okay? What about this one? How do I simplify this? This is what? This is x to the what? 5. X to the 5 minus 3. What's 5 minus 3? Squared. So this is x squared. What about the next one here? This is what? This is x to the 3 minus 5. What's 3 minus 5? Negative 2. Will I leave that as my final answer? No. Why? I can't leave that as a final answer. That's a negative exponent. But I can write this as 1 over x squared. Now, what this brings into play, there are a couple ways, with many of these, many different ways of looking at this. If I've got x to the 5th over x cubed, that's x to the 5 minus 3 or x squared, okay? Another way of looking at x cubed over x to the 5th, you can write this as 1 over x to the 5 minus 3. So I can say, which of these is bigger? 5, so I can say 5 minus 3, but leave the answer in the denominator. So this becomes 1 over x squared. So I'm going to get the same answer if I did this, x to the 3 minus 5, x to the negative 2, and then take that final answer, 1 over x squared. So you'll get the same answer. What's this one here? Yeah, x to the 4th over y to the 4th. Okay. See, this is all pretty easy stuff, right? Okay, then it starts to get a little bit harder, I guess. Okay, so look at this one. What's happening to the 2 out front? Is it being squared? No. What's being squared? X to the negative 1 and the y. Okay, so the 2 is just along for the ride, so don't confuse that. So a couple of things I can do here. The first thing I want to do, I can't just move this x to the bottom because it's not x to the negative 1, it's x to the negative 1 what? Squared. So why don't I just distribute this first? This is 2 times x. What is the x going to be to what power? What do I do with these exponents? Multiply them. So this is 2x to the negative 1 times 2 y squared over x squared y to the negative 3. So this is 2x to the negative 2 y squared x squared y to the negative 3. How do I get rid of those negative exponents? Right, so if I were to move this x to the negative 2 from the numerator to the denominator, it would become an x squared. If I move this y to the negative 3 in the denominator and move it to the numerator, it will become a y cubed. Right? So this is going to be 2. Let's move this down. So I get x squared, y squared, and then look down here, I've got an x squared, and instead of a y to the negative 3, it's y cubed. So what's this final answer? 2y to what power? Over x to the 4th. Okay. So what makes this hard is, like, you had negative x, you had multiplying of exponents, you had negative exponents, you had adding exponents. All the rules of exponents were in one here. I never asked you which rule you were using. You just had to know what properties of exponents to use. Okay, and that's as simple as this can get. No negative exponents. Next one, hard or easy? What do you have to look at to recognize to say this problem is going to get a whole lot easier because of what? Yeah. This expression raised to the 0 power is what? 1. So this is 2x to the negative 2 over x. Now, what's wrong with this? Cancel the x's. Can I just cancel the x's? You could if you wanted to lose points, but you don't want to do that, right? Okay. How do I take care of this negative 2 here? I could take this from the numerator to the denominator. So I could write this as everyone agree with that? Okay. Now, how do I simplify this further? What's being squared? Not just x, but 2x. So this is 1 over 4 x squared times x. What's x squared times x? Okay, so this is 1 over 4 x cubed. Yeah. Okay, pretty good. Too much for the first day? No, come on. You're a junior. You're much more mature than any of these kids, with the exception of Elijah. He's a junior as well. You guys should be setting the example. Okay. They progressively get to where they just look like, okay, a little bit harder here. Okay, look at this one. The next one here, a squared b to the negative 1 over 2a cubed b squared all cubed, okay? One of the strategies with a lot of these is, well, there are a couple of things. You could take care of that negative exponent to begin with, or you can just take care of what this cube is on the outside. A couple ways of doing that. Let's just take care of this cube. What is being cubed? Everything. So a squared cubed, what's a squared cubed? That's a to what power? 6, okay? B to the negative 1 cubed. What do I do with my exponents? I do what with them? Multiply. So this is a to the 6, b to the negative 3, over, what's 2 cubed? Let's call it 8 for today. What's a cubed cubed? That's a to what? A to the 9th. I multiply exponents. And then b squared cubed. What do I do with the exponents? Multiply them. That's b to what power? 6, okay? Am I done? No, I got multiple places of a's, I got multiple b's, I've got a negative here. So this is, I can just write this as a to the 6 minus 9, and then b to the negative 3 minus 6, all of that over 8. Rules of exponents. A to the 6 minus 9. Remember, that's what we're doing. A to the m over a to the n is a to the m minus n. Okay? So a to the 6 over a to the 9th, that's a to the 6 minus 9. This is b to the negative 3 minus 6. What's 6 minus 9? Negative 3. So this is a to the negative 3. What's negative 3 minus 6? So this is b to the negative 9. All of that over 8. Am I finished? Why am I not finished? I got negative exponents. But you guys are so smart. How do I make those things positive? Yeah. There's my answer. 1 over a cubed b to the 9th. Okay? Now, other ways to have done this problem, I could have simplified at the very beginning. I could have simplified my a's and b's at the very beginning and then cubed everything as the last step. Okay? So let's try it that way. Let's see if I think I have enough space here to do it. So this is a to the 2 minus 3, b to the negative 1 minus 2. Okay. What's 2 minus 3? Yeah, so this is a to the negative 1, b to the negative 3 over 2 cubed. So this is 1 over 2ab cubed cubed, which is 1 over 8 a cubed b to the 9th. Same answer, okay? So like I said, there are multiple paths of getting to this answer, okay? As long as you're obeying the laws of exponents, you're going to get there. So what I did, I just chose to cube everything and then simplify. You could have simplified first and then cube everything. Either way. You're not done with your final answer until you have everything with positive exponents. Okay? Let me change colors because I'm sort of running out of room here. What do you think my strategy is for that next one? Right, I could distribute the negative 2, or instead of, I could take care of that negative exponent to begin with. There are many things I could do. You know? So what I could do, let's write it like this. This is c times d to the 4th to the negative 2 times d squared over c. What did I do there? Instead of d to the negative 4th in the denominator, I made it d to the 4th in the numerator. Okay. Now I've got this all raised to the negative 2 power. How can I make that negative 2 exponent a positive 2 exponent? I can just write this as 1 over cd to the 4th squared. Okay. So now this is 1 over c squared d to what power? Right. So this is going to be d to the 2 minus 8 over c cubed. What's 2 minus 8? That's d to the negative 6 over c cubed, which is 1 over c cubed d to the 6. Let me write that a little bit better here. 1 over c cubed d to the 6. Pardon me? Which part? So this is one of those that didn't look too complicated, but we had two different negative exponents. We had powers of powers. We had quotients. We had products. Every exponent rule that we cover, with the exception of raising something to zero power, is in this little problem here, okay? There are many places you can make mistakes. There are arithmetic mistakes. So you need to slow down and make sure you're checking your work on all of this, okay? Now, there are powers that are good to recognize. I'm not going to test you on these, but over time, when you see numbers like 16, you'll make your life a lot easier if you know, oh, that's 2 to the 4th. 32, that's 2 to the 5th, okay? 27, that's 3 cubed. So these are things that pop up repetitively. Some of the other ones, not so much. Like if you can't figure out that 2 to the 9th is 512, you just take 512 divided by 2. You get 256. Divide that by 2. You can figure this out without a calculator, but just doing your prime factors. Now, let's take a look at some common exponents. Instead of expressions with variables, these are numbers, just to make sure you're very comfortable with what the exponent does, mainly with positive and negative signs. Now, if you guys missed the first one, I'll go back and change your grade from semester 1 to an F. The first one, okay? What is this? What's 2 squared? Okay, you know that, okay? No one got an F, okay? So you're good. So 2 to the 4, 2 squared is 4. Now, how is that different than the next problem? What's being squared? Negative 2. So this is, it's still 4 because it's negative 2 times negative 2, which is 4. Okay, I get the same answer. But the point is, it's not negative 4. That one is also 4. Now, how does that one differ from the next one? What kind of number is this, positive or negative? That's going to be a negative number. That is the negative of what? The negative. This is the negative of what number? 2 squared. Okay. You look at your exponent. What's immediately to the left is what the exponent applies to. So what's immediately to the left of this? Negative 2. So negative 2 is being squared. Okay. What's immediately to the left here? Not negative. What's the only thing it touches? It touches the 2. The 2 is being squared. The negative applies to everything. So this is the negative of 2 times 2. What answer is that? Negative 4, okay? So what people would tend to do, they'll say like, oh, that's 4. It's not, okay? This is negative 4, okay? If it was going to be 4, it'd have to be this. So this is negative 2 times negative 2. This is a negative number. It's the negative of 2 squared, okay? Now, 2 to the negative 2. How do I deal with 2 to the negative 2? Yeah. This is 1 over 2 squared. What is that number? 1/4. Okay? Negative 2 to the negative 2. What is that? How do I deal with that? How do I deal with the negative exponent? Yeah, so this is 1 over negative 2 raised to what power? Second power. What's negative 2 to the second power? That's what? Negative 2 times negative 2. What's negative 2 times negative 2? 4. So this answer is what? 1/4. Okay? Now, how is that different than the next one? The next one is going to be what kind of number? A positive or negative number? It's a negative number. So it's the negative of 2 to the negative 2. So it's the negative, you can think of it like this, of 2 to the negative 2. How do I deal with 2 to the negative 2? That's 1 over, I got a negative 1 over 2 squared. What is this number? Negative 1/4. So this is where this stuff starts to all run together, okay? Keep in mind that when you've got a parentheses, everything in the parentheses applies to that power. When you don't have a parentheses, only what's immediately to the left applies to that exponent. What about 1/2 to the negative 2? How do I deal with that? Yeah, so I can write this. This is the same as 2 over 1 to what power? When I flip the fraction, I could change that exponent, because if you think about it, if you've got 1/2 to the -2, that's 1 to the -2 over 2 to the -2, which is 2 squared over 1 squared, which is 2 over 1 squared. So with fractions, I can just flip the fraction, take its reciprocal, and then this exponent becoming a negative just becomes the positive exponent. So that's what we did in this one. What about the next one? Next one's going to be what kind of number? Positive number or a negative number? The next one's going to be a negative. It's a negative of, pardon me? Yeah, this is 4. Okay. So in this case, this is the negative of, I'm going to write that as 2 over 1 squared, right? What's 2 over 1 squared? Yeah. Well, -4 in this case. Okay. So all good stuff. Like, yeah. So like the biggest challenge here is just slow down. The mistakes that are made here are arithmetic mistakes. Okay. So you want to be. Which one? Yeah. So the exponent only applies to what's immediately to the left. So immediately to the left is a 2. Immediate to the left of this is a -2. The parentheses makes the difference. Okay. So the exponent never applies to 2 things. It only applies to the one thing. Okay. And a few more, and then we're done. Okay. So evaluate these expressions using properties of exponents. So -3 squared times 5 all to the 3rd power. Okay. So what's being cubed? Everything that's here. Okay. Now, what is this number? This number right here. -9. Okay. So I've got a couple ways to do it. I can write that number as -9 and then cube it. I could write it like this. This is -1 times 3 squared is 5. All of that's being cubed, okay? So what's negative? So I'm going to have -1 cubed, 3 squared cubed, and 5 cubed. So what's -1 cubed? -1 times -1 times -1. -1. This is going to be 3 to the 6 and 5 cubed. Correct. 3 to the 6. 3 to the 6. How do I figure out what 3 to the 6 is? Well, it was there, but like if I don't know that, so 3 squared is 9. 9 times 3 is 27, so it's 27 times 27. So that's just going to be, I'll go ahead and write it. 3 to the 6 is 729. So this is -729 times 125. Well, there's a negative here. Okay. So 729 times 125, that's 991,125. Yeah, so multiple ways of doing this. This is -9 times 5. This is -45 cubed. Okay. So what you did was this is -9. That's 5. -9 times 5 is -45. -45 cubed. So if you had your TI, but if you didn't have your TI, you would just say, well, that's 45 times 45 times 45, 91125. So you get to the same answer, -91125. So what Ari is pointing out, there are multiple ways of getting to the right answer here with many of these. Let's look at this one. Okay, when I see this negative exponent, how can I deal with the negative exponent to begin with? Just flip the fraction. So this becomes 3 squared over 1 to the 4th squared. What's 1 to the 4th? 1. What's 3 squared? 9. So this is just 9 squared, which is what? 81. So some of these, like, okay, it looks more complicated than it really is, okay? So this is 9 over 1, that's 9 squared, that's just 81. Okay, the next one. Yeah, what's being raised to the negative 2 power? Everything in the parentheses. So this is 4 to the negative 2 times negative 2. Remember, I multiply exponents. And this is 3 to the 2 times negative 2. I just multiply exponents, okay? I'm trying to trick you up with the negatives, but all you do is just multiply exponents. What's negative 2 times negative 2? That's 4 to the 4th, okay? And this is 3 to what power? Negative 4th, okay? So 4 to the 4th, that's 16 times 16, which is what? Is that 256? 256? This is 256 times, yeah, sorry, back up. Over 3 to the 4th. What's 3 to the 4th? 81. So this is just 256 over 81. Okay, what about the next one? I got a negative out front, I got a negative exponent here, got a negative exponent here. What do I want to do? Okay, so Elijah's saying let's distribute this negative exponent inside. Oh, no, you can't do that. So this negatives are going to be along for the ride. You want to come show us that? No. So here, I mean, like I said, there are multiple things. What I could do is say, like, I don't like this negative exponent here. I can move it up here. I can move it in the parentheses first. 2 squared times 3 squared, okay? Then I can deal with this negative exponent here. Or I could start with this negative exponent and just flip the fraction. Then you're going to have another negative exponent. So let's work this 2 ways, okay? First way, let's deal with what's inside the fraction. So this is going to be a negative. I'm going to have a 2 squared and 3 squared. All of that to the negative 2, okay? You see how I got there? This 3 to the negative 2 that was in the denominator became a 3 squared when it moved to the numerator. Okay, so this is just going to be negative of 2 to the squared times the negative 2 power. That's going to be 2 to the negative what? 4th. And then 3 to the negative 4th. So that's just going to be 1 over 2 to the 4th, 3 to the 4th, which is 1 over 16 times 81, right? Yeah. So what is 81 times 16 is 1296. So this is 1 over 1296. Okay. Now, another way to do this is let's take care of this exponent here to begin with. So I could say this is 1 over, say, 3 to the negative 2, 2 squared, all of that squared. Okay, so I took care of this negative exponent to begin with. Pardon me? Oh, it should have stayed here. There we go. So that's my mistake.
Look, so the 36 is negative to the negative 2, right? You put it in the bottom. So it's also. But when I say take it away, he did it, and then you put the negative.
Okay, when I get to here, I've got a choice of what I do. I can distribute this square, and I'll get 3 to the negative 4th, or I could just move this. I could move this 3 to the negative 2, move this to the bottom, okay? So I could write it as this is negative 1 over 3 squared 2 squared squared, which is negative. This is what, 9 times 4? So it's 1 over 36 squared. Either way, I'm going to get 1 over 1296, okay? So here's the thing. There are so many places you can make mistakes on this, okay? You just got to be very organized with all of the rules of exponents, making sure you've got negative exponents, knowing what's raised to the power. Everything in the parentheses applies to that exponent, okay? So I can start inside and deal with negative exponents to begin with, or outside and deal with negative exponents. I can distribute all my exponents and then deal with negative exponents in the end. So I could have just said, this is 2 to the negative 4th, 3 to the 4 over 3 to the 4th. So many different ways to deal with that. Okay? I think that takes us to the end of this section, and it does. Okay? So you've got homework to look at. If you don't have your book, guys, you know where to find everything. Algebra 2. You know, this is the same as last semester. You can always come to this link and you will find everything that we're doing. So we are in exponents, and so everything we did today should be there, and then there's your homework. The other thing that's on haiku, let's see if I have the textbook. I think all I have is the answer key. You'll have to let me know if you see any mistakes. What do you notice about the answer key this year, this semester?
Oh my gosh, it's tight.
Yeah. So
Oh my goodness.
everything is out there. So hopefully that helps you. And there still may be mistakes, but it won't. You'll be able to read my writing on this. So anyway, so it's all out there. Okay. That should be it.